All right, example 2, avoid making a false prediction. So we'll look at this example. You'll come across stuff like this in the book as well and in your assessments. So Mr. Cruz gave an assignment worth 30 marks after marking the first 5 papers. He was concerned that the students did not understand it. He predicted that most students would not do well. So we see the marks here based on his sample, predict the average mark for the whole class. So these are the first ones he marks. Probably depends on who he's marking first, but these are his results. Well, if we have to find average, add up every penny, divide by how many. Maybe you learned a song when you did mean, median, and mode in grade 7, but we add up all of the marks and we divide it, and that should give us an average of about 18. So an average mark of 18 out of 30, he would be maybe disappointed with a class average of 60%. Okay, so he's thinking, okay, I don't think they did very well on this, so I might have to explain this assignment again. So based on those first 5, however, this example shows us all the marks. So these were the first 5 that he found. But if I start looking at some of the rest, we start seeing some better marks later on. A lot of marks over 20, got some 28s, 27, very few that are this low throughout the rest. So could that make him make a false prediction? And it looks like it has. So if you actually add these all up, I made the calculation already. I added them all up. You should add up to 649, all the scores. So you can try this and make sure that you're able to just add them all up. And there's 30 students, so you divide that by 30, and you get a much different average mark, or at least pretty significantly different. 21.63 would be the mark out of 30, which gives you a better average, something like 72%. 72%. So when initially he thought the class average was 60, it's actually 72%. So if we didn't do this extra work, then we would have made a false prediction thinking, okay, everyone's bombing this assignment or not doing so well, not doing as well as they could, but it's actually not as bad. It's actually 12% higher than if he would have just taken those first 5, right? So that's B. The show you know asks, use the example, what if he had marked the last 5 papers? So what if he had taken these ones first? So again, we could take those ones and see what that looks like. But if you add up every penny, divide by how many you have, so take those, divide by 5, you get about 21.4, which is roughly, I believe, the same percentage. 21. Yeah, so 71.3%-ish. So a lot closer to your percentage. So if you had taken the last 5 papers, that's a lot more indicative of the whole sample. So in general, if your sample is 5 out of 30, maybe that needs a few more to make an actual reasonable sample. 5 out of 30 isn't a ton, so you could do even a few more, just always make sure. Okay, then example 3. So this is one where you will definitely come across questions like this on your quizzes and your test. So make sure you're familiar with how to do this. So Youth Association has 400 members and they're figuring out what they want to do. Swimming, rock climbing, watching movies, bowling. You can see that each team has 100 of them. They all voted different. What's the probability that a member of any group will choose swimming? Now, this is getting us to look at the difference between theoretical probability and experimental probability, though it doesn't use the words in this question. But if I'm looking at the probability, if I don't think of anything else, if I just think, okay, the theoretical probability, well, there's 4 different options. So presumably, if there's no other reason to believe, we would just say, well, 1 out of 4. It's a 25% chance they would pick anything. There's no reason to believe one would be more interesting or better than another. Okay, so the theoretical probability would be 25%. Then I would expect, if that was true, I would expect 100 choose swimming, 100 choose rock climbing, 100 movies, 100 bowling. But we can see right away that actually this has higher numbers. It's definitely not theoretical. So it's not going to be true. So the assumptions I made was that everything is equal. They're all equally likely. Okay. So then we get into some math in C. Based on the survey results, predict the probability that a member will choose swimming. So based on the survey results, well, you can just add up all the ones that chose swimming, which I did already. You get 65. Okay, and then the probability that they would choose swimming would then be 65 out of the total, favorable over total. There were 400 people who took this survey. So 65 out of 400 is only 16.25%. So it's a little less than 25%. So compare your answers in A and C. Well, if all things were equal, we would expect 25%. This is only 16%. So that's just going to show that the theoretical and the experiment after we actually do the experiment or do the survey is always going to be different. It's pretty rare that you would get the exact percentages. Okay, so that's how many would choose swimming. Okay, the show you know kind of builds on this. Based on the results, what's the probability that they would want to watch movies or go bowling? So we could do the exact same thing. We would just add up all the ones that chose movies or chose bowling, and then we could do each of those questions separately. I think you should add up to 200 for this one, and for bowling, 71. Okay, so we could do the exact same math as we did over here. 200, that should be some easy math to do. 200 out of 400, that's half the kids. Okay, 50%. And the other one, 71 out of 400, you get roughly 17.75%. Okay, so obviously watching movies is the most popular of the options. We weren't asked for rock climbing, but we could figure that out just by subtracting from these percents. Probably a really, really small percent. Okay, that's A. If you were the youth coordinator planning the activities, how would you determine the favorite activity? So in other words, would you use theoretical or experimental? And typically if you had the choice, you're probably not going to choose an activity that no one likes to do, right? That's not going to be very fun for everyone, so you might choose watching movies. However, if I wouldn't even have that as an option. I would go do something fun, go do some moving around. You can watch movies on your own. So anyways, those are the types of questions you're going to be asked for. So a little bit more math than 11.3 here. So 435, you got some questions you can practice here.